Alright, hi guys. So today I'm going to be explaining the absolute age dating of rocks, which is a method scientists use to determine the actual age of rocks in years. I also highly recommend, if you guys are interested in it, to just check out the physical geology textbook and read chapters 19.4 on isotopic dating methods to help you out with a lot more of this, because it goes into a lot more detail than this short little video is going to. So just before we get into it, just a little bit of background. Before isotopic dating, fossils only gave scientists relative ages, meaning they could tell what was older or younger, but not the actual age in years. So absolute age dating changed that for a lot of scientists. So what is absolute age dating? Absolute age dating is a method scientists use to determine the actual age of a rock, fossil, or geological event in years, usually by measuring it by radioactive decay in minerals. And then here, sorry, it's a little weird quality, but I just wanted to put a picture kind of depicting the difference between relative dating and absolute age dating. So obviously on the left, it's just going younger to older, and then on the right, it's by actual year, so it's a lot more accurate. So, what is radioactive decay? Radioactive decay is the process where unstable atoms slowly break down into more stable atoms over time. Because this happens at a constant and predictable rate, scientists can use it like a natural clock to measure the age of rocks. So, parent and daughter isotopes. Inside rocks, we have a parent isotope, which is super unstable, and it decays into a daughter isotope, which is very stable. So, by measuring both of these isotopes, scientists have been able to figure out how long the process has been happening over the course of millions and millions of years. Yeah, so then again, I just put another little image kind of depicting the difference between a parent and a daughter isotope. So, as you can see, it's starts out with kind of like an equal ratio of parent to daughter isotopes, but as time progresses, these parent isotopes then turn into daughter isotopes, which then kind of balances out and determines how old these rocks really are, and that's again over the course of millions and millions and millions of years. So then obviously just kind of tying into parent and daughter isotopes, there's also a half-life. So a half-life is how long it takes for half of a parent isotope to decay. And for example, the textbook talks a lot about potassium 40 and argon 40. So potassium 40 decays into argon 40 with a half-life of about 1.3 billion years. So that means that every 1.3 billion years, half of the potassium turns into argon. So then obviously like combining the two and tying it into one another, this just kind of talks about how scientists actually date the rocks. So scientists determine a rock's age by measuring how much parent isotope is left compared to how much daughter isotope is formed. So this ratio basically tells them how long that decay has been happening, and that just entails how old that rock is. So, what rocks actually can be dated? Um, Isotopic dating is typically done on igneous and metamorphic rocks because these two rocks are able to form minerals and they crystallize and trap isotopes inside of them. So, these two give you the most accurate and the best data that really tells you the actual age of the rocks. So another super important component to the absolute age dating of rocks is zircon. It's a super useful mineral, and this is because it contains uranium, and there's no lead when it forms though. So any lead found in zircon must come from any type of radioactive decay, and that makes it super reliable for all of this age dating to occur. So then here I just kind of went on a little like rampage. I got a little curious, and the only limitations I could really find for absolute age dating was that heat or metamorphism can allow atoms to escape and reset the isotopic clock, which makes ages less accurate. So also that's obviously for igneous and metamorphic rocks, but for sedimentary rocks, they cannot be directly dated because they're made from fragments of older rocks with a bunch of different mixed ages. So then why does this absolute age dating matter? Isotopic dating allows scientists to determine the actual ages of rocks and understand Earth's geological history. So that is the primary reason why we know that Earth is billions and billions of years old. And then lastly, just to kind of summarize, absolute age dating uses radioactive decay inside of rocks to calculate their age in years, making it one of the most important tools in geology. Therefore, age dating confirms rocks and age in real years. Thank you guys.